And here's part 2. This is station 1 on our science lab, the first one of the year here at Kirtland Central High School. In this particular one, I'm asking them to please use a measuring device, and I'd like them to measure an index card. Let me see if I can pass. There you go. An index card, a lined sheet of notebook paper, a wooden block, and this plastic test tube holder. It's some kind of tube holder, so anyway, we're going to measure that. For the purposes of our discussion, when I ask them to measure length, length is the longest distance being measured. Width then goes on the other axis, going perpendicular across. So for an index card, we lay this up here, and I have to do this one-handed because I'm holding the camera. But we line that up with the 0, and we have to make sure and line it up with the 0. And we come down here, and I see 12.5 or 12.5 centimeters. So for our length is 12.5, and we need to include the units, so we make sure and include centimeters. And in the width, we turn this 90 degrees, and we come out to approximately 7.5 centimeters. For the sheet of paper, we line that up, and we come down here, and we find that it's approximately 26.5 centimeters. And then if we rotate it on its axis and line it back up, it comes out to about 20 centimeters. So there's our 2 sheets of paper right there. Wooden block. And those of you that knew me back in the day when I taught wood shop, this is a 1x4 piece of pine, but we also know it's not exactly 4. All right, so we line this up. It comes out at 22.5 centimeters on the length, and we rotate it 90 degrees, and we come out at 9 point. Ooh, this one's going to be a little tougher. Let me get that lined up a little better. This one comes out to 9.2 centimeters wide. Now, I had students ask me, where did you get the 2? So, it comes up to the 9, then I start counting the marks. There's 10 marks in between the numbers for the millimeters. So this is 1, 2, lines up here with the 2, so therefore 9.2 centimeters. For our blue test tube holder device, we drag him over here and line him up. Now, he's got kind of a curved corner. So I need to, let me get this around here, so I need to make sure and try and line the corner up to where I get that. And then come down here and read it. This is going to be 16.3 centimeters. And then if I turn it 90 degrees and bring it back and line it back up, we're going to come out at 8.8 centimeters wide. That concludes station number 1. We're now going to get up and move over here to station number 2. Station number 2 asks, wants to know if we can read the Pyrex. Can you understand? And it asks, really, it wants to know the total volume and the measured volume of these containers. So we'll start with the flask. As you know, this is a flask, and it says it is a 125 milliliter flask. It says it right there under my thumb. So the total volume of this flask is 125 milliliters. And what does it measure? Well, once again, the highest measure on this flask is 125 milliliters. So in this case, the 2 measures are the same. But let's check out our beakers. Here's the small beaker. And in our class, these were not allowed to be touched because I wanted people to just look at it. But for you on the camera, I'll move this for you. So this is a 150 milliliter beaker. That is the total volume of the beaker. 150 milliliters. But as we measure it, right there it is. The measurement, we have lines up to 140 milliliters. So there's that one. Then we have the medium beaker. The medium beaker here is a 400 milliliter beaker. And the measured volume on this one is 300. Now we have a line above. That's the one that's right here behind my finger. If the student wanted to tell me that that was 325, I would be fine with it, but I would really was looking for if they could just tell me the number. In this case, 300 milliliters. So it's a 400 milliliter total. Whoops, I did that already. 300 milliliters is the measured. Then we have a really large beaker here, and it's not one of the largest we have. It's pretty large. This one's a 600 milliliter. So 600 milliliters. And the measured volume on this one is 500, and there is no line above, so it is 500 milliliters. Let me put that down. Whoops. Getting ahead of myself. Getting excited. 500 milliliters. Now, we also have a graduated cylinder over here. And for my graduated cylinder, I wanted to know what is the volume on this one. In this case, it tells you right there. Now notice they use a small L, 100 milliliters. And this is where I allow the students to go either with a capital L or a little l, as long as it's with another letter that tells me it is milliliters. Okay, moving over. Let me get up here. Now, on this one, I have one last one here. I want to know, what is the volume of liquid in this cylinder? And I reminded the students that when you're looking at this, liquids in these graduated cylinders and test tubes look like they're trying to crawl up the side. This is called the meniscus. And when we look at this, we want to read this across the bottom of the meniscus. So let me zoom in here. Let me see if I can get us turned where we can see this a little better. So we have 55 milliliters. Then we have 56, 57, 58, 59, and 60. So 59, 58. This one's sitting right at 57 milliliters. So we will write that down, 57 milliliters. And now we've completed station 2. We walk. Let's look around the lab while we're going. Wow, quite a nice little lab they have set up here. The building, this particular room was built in about 1990. It was an add-on to the original, and they updated a little bit of it. Okay, now for this particular station 3, using the device supplied, which is a tape measure, we would like you to please determine the volume of the box. And I give them the formula: length times width times height equals volume in whatever it is cubed. I also tell the students you may use the calculator. Alright, so I'm going to set you down here. Okay, so I have to set you down a little bit, but I'll try and do this where you can see what I'm up to. We're going to lay the tape measure down using the metric side. This comes out to 44.5. 44.5 is the length times the width. The width is, and I had students today doing this in inches because inches is here. We'll see how many of them are not going to get credit. This one we're going to call 28.5 across the width, 28.5. And then I'm going to just flip the box like this. There we go. I'm going to flip the box like that so you can see. And I've got this laid down here, and it is 22.5 high. So there we go. We've got the measurements of our box. Now, simply all I have to do, and this is the part that really freaks students out, and this is 24, I don't know where I got liters, but it's centimeters, centimeters, and centimeters. So now let's use our handy dandy calculator here. We'll turn him on, and we are going to just input the measurements. So it's 44.5 times 28.5 times 22.5 equals, and I get 28,535.625, or 28,536 cubic centimeters. So let me write that down. 28,535.625. Let me clear that now. Little trick that I use when I'm doing calculations is that when I want to check my math, I'm going to run it backwards. I'm going to input it backwards. So here we go. 22.5 times 28.5 times 44.5 equals, and I get the exact same number, 28,535. There we go, 28,535.625. So if I round this up to the next whole number, I get 28,536 centimeters cubed. The cubed comes from the length, the width, and the height or the depth, the three dimensions that go in to making that. So that's where that came from. Alright, now the second one that I had over here for station number 3. Station number 3, I had a logic problem for my students. Many of them were having issues with it. You have a container of a known volume. You have a container of unknown volume. There's nothing on here to tell us what that will hold. I would like to know, how do you determine what the volume of this cup is? Now there's two ways to do it. Now I had students all day doing that. I had students all day that were trying to use the tape measure and wrap it around that. And so I would ask them, are you overthinking or are you underthinking the problem? Most of them realized they were overthinking it. Here's the easiest way to do it. I have a faucet. I'm going to turn the water on. I'm going to fill the cup up. Cup is now full of liquid. Turn the water off. I am now going to pour the liquid into the beaker of known volume. We can measure it, and sure enough it comes out right at 100 milliliters. So on the paper the volume is 100 milliliters. How did you get it? Well, step 1, I filled the cup with water. Step 2, poured the water into the beaker. Step 3, read the volume of the beaker. Now I could do it where I fill the beaker up to its top line and then pour it in there and then do the subtraction on how much I used. Either way are acceptable for this particular problem. And we're on the move again. We're going to station number 4 out of the 8 stations. After we're done with station 4, we'll take a break and we'll come back with part 3. Alright, station number 4 is composed of 4 balance beams, balances. In this case, we have a balance that is a dial-in balance. This is a very precise piece of equipment. Now, it's been very abused. This is the fussy one, I call it. It's been fussing with me all day because I can't quite get it to zero out, but we're going to call it 0. We have two objects that we would like to measure the mass. We have a D cup and we have a block of wood. So I put the D cup on. Now, in using a balance, really simple, we're just going to move this out 10 at a time. Nothing happened. Move it out 10 more. It dropped.
High school staff, teachers, students, or whoever is still in the building, they're going to be running fire alarm tests. So please know that the fire alarms are going to go off, but they are running tests. Thank you.
And with that, we will stop and we will come back and finish this at a later time.